Welcome to the runtime error once again. Today we are here with one more question from Leetcode interview 150 that is called as rotate array, which is of medium level. So what this question says that we will be given one array called as nums, and also we will be given as non-negative integer k, and we need to shift the elements of the array to its right side by k steps. So if you take an example, say for example we got an array as 1, 2, 3, 4 and 5, and my value of k is equal to 2. So question says that we need to move these elements to its right side by 2 times. So our final output will be as 4, 5, 1, 2 and 3. So what we did here is, for the value of k is equal to 1, I shifted 5 to its right side, so it becomes 5, 1, 2, 3 and 4. And for value of k is equal to 2, I shifted 4 to its right side, so it becomes 4, 5, 1, 2 and 3, and this is our final output. So this is what the question says, that we need to rotate the array to its right side by k step. So as I told you earlier that whenever we come across any kind of question, first go with brute force solution. So first solution will be our brute force. As we know that we have given a question as 1, 2, 3, 4 and 5 and value of k as 2. So what we can do is, if you observe this question carefully, can I say that first I will copy this last element in a temporary variable, say called example num. I will copy this variable and I will push all the elements to its right side one by one. Now whenever this place gets empty, I will insert this element, so it becomes as 5, 1, 2, 3, 4. So this becomes at k is equal to 1. Again what I will do is, again I will copy the last element, that is 4, and I will shift all the elements to its right side by one position. 3 goes at here, 2 goes at here, 1 goes at here, 5 goes at here, and here comes 4. So we got our final answer, that is 4, 5, 1, 2, 3 and 4. So what we did basically over here is, can I say I have to copy the last elements k times, and I need to shift all the elements to its right side k times. So I'll simply use the while loop till my k becomes 0. And what I will do is, I will start taking all the elements of array to its right side by one position. So I will simply start from I is equal to n minus 2, which is from over here. It will go till my is greater than 0 and it become minus minus. So what I will do is, if nums of I plus 1, that is this position, will contain nums of I, that is this element. So at this position we will be inserting 4. We will be inserting at 4, and at the end what you will do is, at nums is equal to 0, you will copy the value present at last index. So before we transfer any element, what we need to do is, we need to copy that value. So I will use the temp is equal to nums of n minus 1. So what I mean is, n is nothing but the size of an array. I hope so you got this brute force solution. Now if you try to calculate the time complexity, what will be the time complexity of it? So it clearly says that we are using the while loop for k times, and at the same time taking each and every single value of array to its right till k becomes my 0. So what will be the total time complexity? My total time complexity will be k into n. This will be my final time complexity. And if you talk about the space complexity, it will be of course big of 1, because we haven't used any extra space. So can we do it something better than this? Do we really need to shift every single element one by one to its right side? Say for example, if my value of k is my 100, then what I need to do is I need to shift every single element to its right by 100 times. So this is not an optimal solution. Now cannot do it something better than our brute force solution. So I won't be calling an optimal solution, we will be calling it as better solution, I would say. So second, I would say a better solution. So we know that we have given an array as 1, 2, 3, 4 and 5 and value is equal to 2, which means I need to move the elements 2 times to its right. So what can I do it? Can we use some kind of mathematics over here? We know, say for example 0, 1, 2, 3 and 4. Our final answer is, we know that as 4, 5, 1, 2 and 3. 0, 1, 2, 3 and 4. This is our final answer. Now let's try some mathematics. Say for example I'm at here. So initially my 1 is present at 0th index, but after rotation it has moved to its second index. 2 initially is at first index, but it has moved to its third index after rotation. So can we apply some kind of mathematics over here? We know that 1 is present at 0th index. I need to rotate my array 2 times, so it becomes k, which is my 2, and what I will do is I will apply as n, and we know that the value of n is equals to 5. So it becomes 2 modulo 5, which is equals to 2. So can I say that 1 has come at the index 2? Now 2 is present at index 1. I need to rotate it by 2 times modulo by size of an array. So it becomes 3 modulo 5, which is equals to 3, and we can say that the 2 is present at index 3. Are you getting what I'm saying is? Now let's check how we can do it. Say for example I'm starting my array from 0th index. I need to go till n minus 1. So what I will do is I will get the index as I plus k modulo n, because this is the index where we are supposed to store that element after rotation. And what I will do is I will use one extra array. Say for example array called as answer. So it becomes answer of index equals to nums of I. I hope so you got what I'm trying to say. Now let's make a dry run of our better solution. So initially I'm present at index 0, that is over here. So it becomes 0 plus 2, that is value of k modulo by 5. So it gives us 2. So my 1 will be present at index 2. So here I will put as 1. Now my 2 is present at index first. So I will use 1 plus 2, that is value of k modulo of 5, which becomes 3. So my this 2 will be present at index 3. Now I come over here, my 3 is present at index 2 plus 2 modulo 5, which becomes 4 modulo 5, that is 4. So my 3 will be present at 4th index. Now I come over here, it becomes 3 plus 2 modulo 5, which is equal to 0. So my 4 will be present at 0th index. And when I come here, I got 4 plus 2 modulo 5 equals to 1. So my 5 will be present at first index. And this is the answer which we are looking for. This is the mathematics and this is the case that we need to look at. Now if we discuss the time complexity of this better solution, I would say the time complexity is simple. It was big O of n, which is much better than the brute force solution. But only a problem in this solution is we are using an extra space, and space complexity will be of course big O of n as well. These solutions looks much better than that of the brute force solution. But again, can we get one more question? Can we do something better than this as well? Of course yes. Now let's look at our final solution, which we'll be calling as the most optimal solution. So our third solution will be the most optimal solution. Now what we will do is we will try to rotate all the elements within our array that we has given as 1, 2, 3, 4 and 5, and value of k is equals to 2. Now we will try to rotate within the same array itself. So we have 4, 5, 1, 2 and 3. Can you observe this array carefully? Observe both the quotients array and our final array. What kind of observation you see here? Can we simply say that it is simply we are trying to reverse the array and then reverse first k elements and then reverse last remaining n minus k elements? Let's check. Now what we will do is here, now first I will reverse this original array. So I get as 5, 4, 3, 2 and 1. I have reversed this, so it becomes 0, 1, 2, 3 and 4. Now what I will do is my value of k is equals to 2, right? My value of k is equals to 2. So what I will do is I will rotate first k elements, that is first 2 elements. So it becomes as 4, 5, 3, 2, 1. So these are my first k elements. My array has n elements and I have rotated k elements. Now remaining elements are n minus k. So can I rotate or reverse this remaining n minus k elements? So my final answer will be, it becomes 4, 5, 1, 2 and 3. Is it the answer which we were looking for? Is it the answer which we were looking for? We did it in the same array itself without using an extra space. Now let's implement this. We will be writing code for optimal solution. So what we did is basically we first reverse the array, that is 1, 2, 3, 4 and 5, and value of k equals to 2. Now what we did is first we reverse the array. So what I will do is I will simply reverse array. So it becomes as 5, 4, 3, 2 and 1. Now what I will do is I will reverse first k elements 0, 1, 2, 3, 4. So I will be using 2 pointers, that is called as a start, which is at 0, and end, which is equal to k minus 1. Since my value of k is 2, so k minus 1 is equal to be this one. So my start is pointing at here and my end is pointing at here. Now I will reverse this till my start is less than end. What I will do is I will simply swap it. I simply sort as start and end element, and at the same time I will update their position as well. So I have reversed these 2 elements, or I can simply say that first k elements. Now what I will do is, now I will try to reverse remaining n minus k element. Now what I will do is, again I will be initializing start is equal to k, which will be pointing at over here, and end is equal to n minus 1, which will be pointing at here. Now again I will be writing the same thing, that is while my start is less than my end, and simply what I need to do is I need to simply swap the elements, and again I will be updating my index as well. So this is the final answer we will be getting as 4, 5, 1, 2 and 3. I hope so you got this answer. Now if we discuss about the time complexity, for reversing the array it takes big of n time. For reversing this it will take as big of k time, because we are reversing first k elements, and for reversing this it will take big of n minus k times. So what will be the overall time complexity? Overall time complexity will be big of n plus big of k plus big of n plus k, n minus k. So this will be our most optimal solution, I would say. So I hope so you understand all the 3 techniques used to solve this question. Now let's check out the code which we have written on the Leetcode. So this will be the code which we will be writing in Leetcode. I will be using the language C++. You can perform this in any other language. Their functionality is something different than C++. So before implementing this code, I will try to tell you one more important thing which I missed explaining in the previous part, that is this part, why I have did this k modulo n. Now say for example my array is of size 1, 2 and 3 and my value of k is 2, then can I say my final answer will be 2, 3 and 1. I have rotated this. Now say for example my value of k is equals to 3, then what can I say is, can I say again I am getting the same value. Now suppose say for example my value of k is equal to 4, so what will be my answer? My answer will be 3, 1 and 2 for value of k equals to 4. But what if my value of k equals to 1, which means again my answer is getting as 3, 1 and 2. Can I say I'm getting the same thing for 4 and 1. This is the reason why what I did is, in order to avoid extra rotation, I simply reduce the value of k. If my value of k is greater than or equal to n, what I simply did is I simply took the modulo with n, so that I can stay within n to avoid the extra rotation. So this is what I did. So here I use the reverse function which is inbuilt in C++ STL. You can utilize the same in Java collections as well, to simply to reverse whole array, that is nums. Now I used to reverse the first element. Here you can say that I have added k. So begin will be pointing at the first location, k will be the pointing the first k position. So I have rotated the first elements, and here I have rotated the remaining n minus k elements. So I hope so you got this question. In order to know more about coding and all the interview related stuffs, do subscribe the Runtime Error. Till then, have a happy coding.